Today we're going to talk about converting between different types of units of measurement. And this is going to go with the learning goal. I can identify and solve proportions and use them to solve problems. So this is one type of problem that we're going to solve using proportions. Your book talks about solving these types of problems using rates, and that's another way that you can do it. If you would prefer, you can look at the way that the book explains how to do this, and then you can learn how to do it that way. So in my last video, I talked about how I have a personal goal of running at least one 5K this year. And so I want to know how many miles that is. I am not always very good at thinking about things in metric units because we don't use metric units very often here in the United States, although it is becoming more common. So what I'd like to do is I'd like to take this 5K, and I have to know that K stands for kilometer, and I'd like to take those 5 kilometers and change them into miles to see how far I really am going to be running. In order to do that, I need to use a conversion factor. And a conversion factor is something that you can look up either on the internet or whatever resource that you have. Use it to convert between the unit that you have to the unit that you want to convert to. So for example, in this case, I want to convert kilometers to miles. And our book happens to have a conversion factor that I can use for that. And it tells me that 1 mile is about 1.61 kilometers. When we're converting customary units, which are the units that we use here in the United States, to metric units, which are the units that the rest of the world uses, usually they're approximate. The only one that's exact is when we change inches to centimeters, and that's just because that has been set up as an actual law that 1 inch is exactly 2.54 centimeters. So this is about 1 mile is about 1.61 kilometers, and I'm going to now set up a proportion. So in the last video, Ms. Yoder talked about how a proportion is an equation that we write with that we want to find 2 equal ratios. And so I'm going to use this conversion factor as one of my ratios, and then I'm going to fill in for the rest of it. So I can write this however I want. I could put 1 mile over 1.61 kilometers, or I could write 1.61 kilometers over 1 mile. It really doesn't matter, because remember, with ratios you can flip them over, and so I can write that either way. But I want to write an equal ratio. I want to find a ratio that's equal to that but has 5 kilometers, and then I need to figure out how many miles that's going to be. So I'm going to put a variable in there. And remember that when we solve proportions, we're going to cross multiply. And just be careful here when you're setting up this proportion, you need to make sure that you have like units across from like units. So I made sure that since I had put kilometers on the bottom, that I put my 5 kilometers on the bottom over here. So they are in the bottom of both of the ratios, and that lets me know that I have my proportion set up correctly, and I'll be able to solve it. So I'm going to cross multiply here. I'm going to multiply this way and then this way, and so I will get 1 point, oops, I wrote that in there wrong, didn't I? It should be 1.61x, and that's going to be equal to what I get when I multiply the other one, which is the other way, which is 5 times 1, which is 5. So I'm going to divide both sides by 1.61, and that will give me x equals, and now I need to use a calculator. The answer to the free response question for today is macaroni light bulbs. So that looks like it's about 3.1 miles. So I'm going to come back here and say that x is about 3.1 miles. Here's another example. This is actually a rate. You ran at a rate of 0.15 miles per minute, and we want to convert that rate into feet per second, just so that maybe we're comparing our time to someone else, and that's the unit that they have their time in. So I'm going to write this as 0.15 miles over 1 minute, so that I'm just clear on what I have here. And I know that I'm changing that into feet per second. And so what I want to do right away is change this bottom 1 minute into seconds, because I happen to know that 1 minute is the same as 60 seconds. So I could just rewrite this as 0.15 miles per 60 seconds. So now I have this 0.15 miles per 60 seconds, and I want to change the 0.15 miles over into feet, and then I'm going to divide to get my unit rate, just like I did back in the first video. So if I have 0.15 miles, and I want to know how many feet that is. And so I'm going to put that over here, and I need to think about my conversion factor. I know, and I could look this up or look in the book, that 1 mile is the same as 5,280 feet. And again, I'm being very sure that I have feet across from feet and miles across from miles in my proportion. And now I am going to just cross multiply and then solve the equation that I get when I cross multiply. So if I multiply across the x and the 1, I'm just going to have 1x. I'm just going to write that as x equals, and then I am going to multiply 0.15 times 5,280. And that's 792. So x is equal to 792 feet. Okay, so now, remember back here, we had our 0.15 miles per 60 seconds. So I'm gonna now take that feet amount that's the same as the 0.15 miles, and I have a new rate, 792 feet per 60 seconds. And so now I want to make this into a unit rate because I want to know how many feet I'm going per 1 second. I'm going to divide by 60 over 60, and that is going to give me 1 second on my bottom of my ratio, my rate, excuse me, rate or ratio. 792 divided by 60 gives me 13.2. And this is a rate, so it's okay to have a decimal in this rate. 13.2 feet per second. So if I'm going 0.15 miles per minute, that's the same as going 13.2 feet per second. And I change that over by converting both units. First I changed minutes to seconds because I just knew that off the top of my head. Then I used a proportion to change 0.15 miles into feet. So I rewrote my rate with the feet and the seconds that were equal to the same amount of miles and minutes that I had in the original rate. And then I changed this to a unit rate by dividing by the number of seconds in both of them so that I had how many feet I ran in just 1 second. So I'm going to do one final example, which again, you can skip this if you feel like you're ready to go. Otherwise, you can watch me do this. Even if you skip it, please try to do this problem on your own. I want to change 36 centimeters to inches. So I'm going to say how many inches are equal to 36 centimeters. And I'm going to set up a proportion. So I need to have a rate that is equal to this one. And I'm going to use my conversion factor. I know that 1 inch, and again, you can either look this up online or in your textbook, is exactly equal to 2.54 centimeters. So I write that conversion factor as a rate. And now again, I'm just going to cross multiply. So I will end up with 2.54 times x equals 36 times 1 is 36. I now have an equation that I need to solve. So I'm going to do the opposite operation here. Something's being multiplied by x, so I need to divide by that something. I'm going to divide by 2.54, both sides of my equation. And so I will get x equals 36 divided by 2.54. Big long thing, so I'm going to round this. Let's round it to the nearest whole number. So that would be about 14 inches. So That means that 36 centimeters is about the same as 14 inches. And here are your free response and multiple choice questions. So please pause the video now, and after you answer them, have a fabulous rest of the day.